defining what they're made of. Angles are made up of rays. Okay? Angles are made up of rays. Those rays, first of all, let me show you the symbol that I use for angles. It's a little bit different than the book. I use that symbol for an angle. It's the regular symbol that they use in the book, which is, kind of looks like a less than symbol. The only thing is that I put this little arc through it. When I was taught geometry in high school, my teacher taught it that way. And the reason why they taught it that way is because as you get into later on, into like Algebra 2, we start looking at angles created via parts of circles. Parts of circles have arcs. Circles are a bunch of arcs going all the way around. So that's why the parts of that. Also, it doesn't look like a less than symbol then. So that's why you'll see that. The textbook, put your foot down, please. We talked about that yesterday. The other reason that the book doesn't do that, and the book's handwriting is a lot cleaner than mine. So by putting that in there, you know for certain that it's going to be an angle. So angles are made up of two different rays with same endpoint. Angles are made up of two different rays with the same endpoint. Sir? Oh, just want to separate page. I'll get you the other, because I know some people put their notes on the page. I just want to see how you guys write. Oh, really? Oh, okay. So, what angles do, it's very similar. Remember how we had opposite rays that created a line? That common endpoint was just that point in between where they met. A line actually is an angle. It's a straight angle. It measures 180 degrees. If you take that straight line and you start to turn it, that's where you get different degree measures. Okay? That common endpoint where they meet, that point doesn't change. This point where they meet, do you know what that's called?
Isn't it called like a set? A segment, right?
No. What's that called? What is it? No. Angles don't have midpoints. Okay? Where the two rays meet, that common endpoint. Yes, sir. Exactly.
I'll call it a dot. It's a dot.
This is called the point where this common endpoint is the vertex. That common endpoint is called the vertex.
Whoa.
Now, when you think about how rays were labeled, remember how rays were labeled with two letters? The endpoint was one, where it went through was the other. The endpoint was one, where it went through was the other. So if this was ray AB, and this was ray AC, what point do they have in common?
A.
Correct. So A would be called the vertex. Now, how many points do we have here that create this angle?
3.
3 of them. Very good. So what we would call this is we would call this angle, we would call this angle BAC or angle CAB. We call it one of those two. It doesn't matter which way you call it, but notice what letter is in the middle.
Bar. Cab.
A is. A is in the middle because it is the vertex. The vertex is always, always, always the middle letter.
Bach.
The vertex is always the middle letter. Now, every once in a while, they will label angles with 1 or 3 letters. The only time you can say it's one letter is if it's the only one possible angle. Is there any other angle here besides angle A?
No, yeah.
There isn't. This is the only vertex that's here that has the letter A. The time, what I'm talking about is if we do something like this and call this D, if I say angle A, it could wind up being one of 3 different angles.
CAD.
I was just looking. Oh, I was just looking what you're at because I don't know how many book goes.
It goes,
Interesting. It looks pretty good. It looks pretty close.
it's the same thing except it does those nets for 1-1.
Yeah. So we should get rid of that.
But, yep.
What do you mean?
Yeah, so they do this and then they kind of mix everything together. They put midpoints the same without coordinates.
Yeah, so they put. Okay.
They put the midpoint with coordinates
That's what I
with
thought.
distance formula
I
later
feel
on.
like everyone's ahead of me now. Oh no.
No, it's just
I always gotta check.
it's good fun.
Did you make that in alcohol?
No,
No,
I'm not that creative. It's the newbies.
That's fine. I gotta yell at them because they put find X all over the place. I literally want to take a marker and go onto all of them and circle and say found it, found it, found it,
You
found
should.
it.
Put it on a post-it
Okay,
note.
well, first of all, I found
Sorry, we walk into each other's classrooms all the time. You guys know Mr. Severino, right?
Y'all be interrupting our learning.
Severino?
So if I interrupt somebody learning, I get in trouble with y'all doing something.
Types of angles.
Whoa, it's a right angle, a acute angle, and a scaling.
That's triangle. Very good. You caught that one. So we have types of triangles. You said the other one. So Josh, you said we have what kind?
Right?
Right triangle?
or angles.
Oh, I'm sorry. Thank you. What you said scaling triangle. It's like, yeah, you're right on that one. So
You got a right angle.
you have a right angle. Okay, so we have a right angle. Is it okay if I just use RT for the right? What's the next one?
It's scaling.
We have
That's
obtuse.
a train. It's acute.
There's a Q.
Then there's a straight.
Very good. That's usually one that people forget about. Okay. Those are the 4 types of angles that we talk about. When we're looking at them, what makes a right angle a right angle?
The 90 degree.
Very good. Right angles are always going to be angles that equal 90 degrees. How do you know for certain in a diagram if it is a right angle? Yes, sir.
Those are dots.
Very good. You guys have all seen that before, so that's not anything new. A lot of times in a diagram, you'll see that little box like that. But every time you see that, that means it is a right angle. Okay? You can never assume things are right angles. You can never assume other things, because then you make an angle side side out of you and me.
But what if it's a 91 degree angle?
Then it's
We
not a
could
90.
assume that it could be a
Hey,
90
but,
degree.
but it's not.
But
And
we
you
could
said,
assume.
no, you can't.
Don't assume.
You can't. What do obtuse angles measure?
Greater than 90 degrees.
Greater than 90 degrees, but in our case, less than what? Very good. These are angles that are, I hate to say, all right, I'll use the inequality, that are greater than,
Inequality.
so
Just draw greater than a right angle. A small
greater than 90,
complicated.
but I'm trying not to put too many of
But you
these
don't want
symbols.
to do a count, yeah.
Yeah, I don't want to put too many of the angle symbols, but less than 180.
But why they be like either? Why sometimes they be like 90 degrees and up, and then 180 degrees and less? Like obviously, whenever in 8th grade, the books.
I think that was middle school.
Yeah, they should
That
be
was in
like
middle school.
90 degrees and up. And I'm like, isn't a 90 degree a right angle?
Always.
It should have said greater than 90 degrees.
Yeah, they used to be like 90 and up.
Well, it should have, it might have said, it should have, I would hope that someone would have proofread that book and said, oh, it should see greater than 90, because if you're 90.00001, you're no longer a right angle,
Well, that's what
because
they
it's not
should put.
exactly. So anything, as soon as you get larger than 90 degrees, it's no longer a right angle. So it's any angle that's between 90 and 100, or 180,
That's the
excuse me.
obtuse angle that you read, but okay.
The reason why we say less than 180 is because for our purposes, we're not worrying about multiple what are called revolutions throughout space. We're only looking at the standardized stuff. Okay. Acute angles. Acute angles measure what?
Less than 90 degrees.
Greater than 0, less than 90. Good. So these are going to be angles that are.
And there ain't even no such thing as a 0 angle.
Yeah, there is. Yeah, there is. Yeah, they're greater than that, but less than that. Now, you're saying a 0 angle.
Wouldn't that be a dot?
No.
Wouldn't it be nothing?
No, it's something.
It'd be a straight line.
Wouldn't it be just two overlapping lines?
No.
I'm pretty sure a straight line is a 180 degree angle. I'm right.
Now, just for interesting here, when you take a look at an XY coordinate grid, if you start at 0, that's 90 degrees up, there's 90 degrees back this way, 90 degrees here, and 90 degrees back. That's why it's 360 degrees to get around. Well, if you start at 0, it's still a 0 degree angle. It still has no value, but in trigonometry, it's still important. Okay. It's what we call, and you'll learn about this later next year, these things are called, these axes, when we get to upper level, are called quadrantals. Quadrantals have specific value. 0, 90, 270, I'm sorry, 0, 90, 180, 270, and come back on to 360 for what we call 1 revolution. It's a trigonometry thing that you'll learn about later on, so it's still important that 0 can happen, but it's not an acute angle because the value is 0. Okay? Psst. That's the 4th time I've asked you to put your phone away. If I ask you again, I'm going to write you up. Do you understand that? So why don't you just put it in your backpack so you don't have to worry about
I
it?
ain't gonna mess with it.
How about you just put it in your backpack and you don't even get tempted? It's even easier.
It'll be okay.
No, I have a feeling it's not going to be. Straight angles measure what? 180. Straight angles always measure 180 degrees.
It's more than 190. It's more than 179.
Excuse me. And again, we do not go past 180 degrees when we do this stuff. These are things that you guys have all worked with. You've all done and measured through with one of these.
So protractor.
Yep. Because when you work with a protractor, what are the values that are on there?
180,
It goes from 0 to 180 degrees. Okay.
It goes from 0 to 180.
So protractors all measure from 0 to 180. That's why we only worry about that stuff in geometry. You don't have to worry about beyond that. Okay. There are times when we get into, I don't remember, was there, I think in some of the polygon stuff, we might do like an outside angle greater than that.
Right.
But other than that, we don't have to worry about, for first semester stuff, I don't think that we get into anything like that. Okay? Again, none of this is new. You guys all knew all of that. Right? You guys knew every single bit about that. Now, what we get into is what we call angle addition.
Oh, this is
This is exactly the same thing as segment addition. The only thing that's different is that it has more letters. Remember, segment addition was AB plus BC equaled AC. This one, this is angle ABD plus DBC equals ABC. It's still the same exact premise that if 2 or more angles, oops, share a common vertex, bless you, and does it, I'm trying to think, I don't think it ever came up where you had points in between, so I'm not even bothering with that.
what is that symbol that you just drew?
And a side.
Oh, wait, what about the one up there too?
Angles, remember at the very beginning of the class I showed what an angle symbol looked like?
I know.
You might have done it wrong.
I know what this is anyway.
So what I mean here by a common side, notice This ray BD is the same side for this angle and the other angle. That's what it means by sharing a common side. So what happens here, very similarly to segment addition, endpoint to something to continue on, all you're doing is adding those points together, or adding those values together. It's the exact same thing with angles, but you're just turning as you're going. It's not linear, if you will. It's not creating line segments, okay? It's angular.
So you said ABD plus.
I'm going to write this out in 1 second. And this is where angle addition uses so many letters, it's sometimes messy. So that's why we try to write it as neat. Oops. Try to write it as neatly as I can here. I apologize. My handwriting is always interesting. So if I do this, I would say that angle ABD plus angle DBC equals the big angle of ABC.
So just like segment, you guys, part plus the part equals the whole thing.
Oh, that's
Or the
easy.
little plus the little equals the
Because all you're
big.
doing is adding that angle plus that angle.
That's right. What do all three of those angles have in common?
They're all within the ABC.
B, very good. And what is that B value showing us? That's the counting part. Very good, very good. That letter B, yes sir?
The whole angle is 90 degrees.
We don't know. It doesn't say.
It's a right angle.
It doesn't say though.
You can't assume that. If it's a right angle, they're going to give you that right
It-
angle symbol.
it looks close-ish.
Yeah.
But we can't assume it.
You looked at it.
All right.
All my angles, he was like,
And that's, we don't know for certain. This was just me drawing something real quick. If I put a little box in there, then you would know for certain that it was. Or if it's set off to the side, angle ABC equals 90. But if it doesn't say it, you can't assume it. And that's one of the things in geometry. It's a hard time for kids to understand that it may look like it, but it's not it. Okay? This could be 87 and a half. All right? It could be 92. All right? So what happens here with angle addition is that all you're doing is writing out parts. And these parts are always going to have something in common. And in this case,
it's big.
it's that vertex. As long as they have that common vertex, it all flows itself through, and then you can throw in numerical value. And all of a sudden it looks exactly like what you did yesterday and the day before, but with just a couple extra parts to it because of the lettering. The lettering is what takes a while to look at. Okay? Let's try another one.
Can we do like an example now?
We're getting there. For example, we have the exact same diagram, and we just filled in some random numbers. Everybody get caught off first, right? What were you gonna say?
Isn't the only thing- it's a DBC equals 75.
I want to take that there.
So I'm like, if we already got the English, can we just subtract 35 and we get DBC, right?
Do you know what that means? It means yes. I'm trying to be quiet about it. See? And the reason that that works is because what are the two small angles here? We have angle,
ABD.
let me change my color here real quick. I have angle ABD.
You got DBC or CBD.
You know, a lot of times, you're right, I can go ABD, CBD, but see how I went down to here? I might as well just go back to here.
Yeah.
That's all. I mean, it's not wrong. It's not wrong at all because that value of B is still the vertex, so it still works. And just like we did the other day, it's just filling in the values. Well, ABD is 35 plus something is 110. Josh, what was it?
75.
75. Yes, ma'am.
How'd you get 110 degrees?
How did I get the 110 degrees?
They gave it to us.
It gave it to us. I just made up the number. Yeah. They'll have to give you some bit of information to get going on some of these things. All right. That's what this looks like. Okay. It's a matter of filling in the blanks, exactly the way we did. I'm missing.
It's right there.
It's the same thing as this.
180 degrees. Whoa. Whoa. Whoa.
It's the exact same problem. The only thing that changes, it's not straight across from one another, it turns. All right, it turns. And also when you're dealing with segments, if this was X, Y, and Z, notice it's just shorter letters to write out versus the angles. Instead of 2 things you write down, the angles have the symbol and 3 letters. So it adds lettering to it, so it can, in fact, look a little bit messier, but in fact, you're doing the exact same thing. Happens a lot in geometry. You learn one thing for one topic, and you replicate it for other parts. So, just like Josh said, this winds up equaling 75. Is it the end of the world when you're finding angle measures if you forget to put the degree symbol?
Yes.
Nope. Because 95% of the time, I'm going to forget to put it there too.
See, you did.
Because sometimes you're solving for X, sometimes you're solving for the angle. And honestly, guys, just read what they're asking you to solve for. So if it asks you to solve for the specific angle, if you put the degree symbol in, great. If you don't, whatever, you still got the right answer. I'm okay with that. All right? All right.
Come on, never been right.
Does anything change if we put algebra in there?
No.
Oops. It's on a separate page here, sorry.
I would not want to have your smart read that. That's a lot of stuff.
A lot better than having to write it out by hand every time. Take a second, write that out, and let's look at an example that deals with algebra then. Because just like the other day, when we did numerical stuff, it was real quick and painless, it wasn't a big deal. Then we just added to it, added to it, added to it. It's the same thing today. It's just a matter of piecing it together. And as we piece it together, you guys will start to see that, wow, this really isn't all that bad. For an angle? Correct. Negative, for right now, or wait, you can solve for x. X can be negative, but it might give you a positive value. But if you got it, that doesn't happen very often. But let me ask you guys this real quick. Do negative angles exist in geometry?
No.
No, they won't. Will negative angles exist in algebra 2?
Yes.
Yes. Negative angles just means it's just a different direction.
Yeah.
Okay, that's all a negative value means for as far as an angle. Regular angles, what's it, Josh? Regular angles in algebra 2, if they're positive, they go counterclockwise. If they're negative,
They go.
clockwise. That's all that means. Now, Josh, your question?
Isn't it x equal, like, isn't gonna be a fraction, right?
I don't know. I haven't done the math yet. But what I will do is, yes, ma'am. Sir.
I did it, and I was just gonna single the digit number.
I don't know. I haven't done it yet.
Who else got a fraction?
Let's start with what we know. Okay.
Should I add a zero?
I don't know. I haven't done it yet. We're getting there. Let's start with what we know. We know the big angle, the whole thing, NRQ is 78.
Oh, dang, I didn't even see that.
So we start by writing down what we have. We have angle NRP plus angle PRQ has to equal angle NRP. Q. Always start with that. The reason that I start with that, because now I can figure out which parts go where. That's the idea here. Okay? Now, angle NRP, excuse me, is the 8x plus 7. The next one is 4x minus 1. And the whole thing
Oh, I know what it is.
is 78.
Oh, I didn't look at the top.
That's a.
You have to read the instructions, guys.
Wait, hold
All right. And now you are at the point where all you have to do is combine your like terms. What's 8 and 4?
on. It's 4.
12.
I got x equal 18.
So I have 12x. 7 minus 1 is 6. Is 78. Now you're at a two-step equation. What do you do next? Subtract the 6. Good. Subtract the 6. You get 12x is 72. Oops.
Oh, never mind.
And now what do you do?
It's 4.
You divide out by 12 and you get x equals 6. Very good.
Oh, I did it backwards.
But it didn't just ask you to solve for x, did it? It asked you to solve for PRQ. So you have to substitute that in.
4 times 6 is 24.
So you have, yep, good. 4 times 6 is 24.
23.
Subtract 1, you get
23.
23. So your answer should then be
55.
23. No, it asks you to find PRQ. That's what we just did. Oh, yes. I said your answer is, and you said 55. Like, oh, no. I didn't know. Yes, you are right. Then the other one would be 55. Okay. Thank you, sir. No problem. Okay. Not too bad.
No, this is.
Remember, it's the idea that you have to just read what you're starting with and just fill in the blanks. And it looks exactly like what we've been doing. Okay?
Oh, it's the next problem.
Do this one.
We can't see it. I'm sorry.
Now we can.
I still can't see it. I'm still blind.
Pay attention to what it says at the very top there. It tells you what the whole thing is. Because apparently most of you guys have forgotten to do that. But take a second and fill in the blanks.
You know,
Okay?
it's right in front of you.
Take a second and fill in the blanks.
18x plus
Don't get frustrated. Don't get frustrated. Think of it as a segment that turned. Think of it as a segment that turned. Yeah, you'll have, once you solve for x, then you have to go back and substitute it. I'm sorry, what's that? Well, no, because what is 11x plus 9? It is what? Yeah, it's an 80. No, and that's the reason why right now it's up there two times. So 87 is going to be that. Same deal. Plus. C, 18 is that whole thing. That's why we went out those statements. So that when you get to the point where you go in the blanks, you won't have
77.
So do it that way by taking the extra 10 seconds to write it out.
14. 49.
What'd you say?
Please consider.
BBC 49 is what you got, right? Who else got 49? You get 40. What teacher?
Hey guys, seriously, write out this statement. Write out what everything has to wind up being, just like we did with segments. Don't skip this step of writing out what they're made up of. If you don't skip the step of what they're made out of, you're going to wind up filling in the blanks. We know this angle plus this angle is that one. So what are the angles? A, D, D.
It's 49 and 86.
When you write that out, you now have the three separate parts that you have to put together. You can't skip anything now. It forces you to know that, oh, this is 7x, this is 11x plus 9, and this is 135. It forces you to create that two-step equation. Exactly. So please, take the time and just write it out real quick because it'll be a lot easier on you, okay? It'll be a lot easier. Yes, ma'am?
He got it. He's smart. He's low. You get 49.
Broke it.
Exactly. All right, so what's 7x and 11x?
70 is 18x.
18x, good. You almost went 77, didn't
Yeah.
you?
Plus 9 equals.
Yeah, because
No,
it's
it's
angle
fine.
addition. This angle plus this angle is the whole thing.
It's fine. You know 9.
Oh, thank you.
Just gotta wait for it to flip back.
So we was gonna get the wrong answer. And I was gonna
Oh, but here's the thing. Remember we talked about this. What if halfway through the problem I accidentally wrote a 9 instead of a 5 and I did everything like I was supposed to? Is that wrong?
Yes.
No. Here's the thing, guys. It is so easy in these problems to do the math right, but accidentally write down one wrong number from the diagram, from what you had written before. It happens all the time. This is why I am such a proponent of making sure you show all of your work. If you show all of your work, and I can see you might have gotten the wrong answer, but what happened was you accidentally wrote 153 instead of 135. Do you guys ever accidentally write numbers flip-flop by mistake?
No.
But if you do all the steps right, are you wrong?
Yeah.
No, you're not. And that's the thing. You're not wrong. It is so simple to accidentally write the wrong number somewhere along the line without realizing it. That's why you show your work. Because so much of this stuff you just press a button on a calculator. If you get the wrong answer without showing the work, then it's wrong. But if you get the wrong answer and you show the work and it was one of those stupid mistakes that you flipped the number, you're not. So make sure.
Some people are supposed to say wrong.
I don't though, and that's and that's okay. It's okay, and that's just some people are like that.
I'm gonna start
All
putting
right.
extra small numbers.
And it's so easy to accidentally, instead of writing 11x plus 9, what happens if you wrote 11x plus 8?
I'm
You're gonna get the wrong answer. But if you did all the work correctly, you solved it the right way, and you substitute back in, and gave you the answer, you know what you're doing. You just wrote the wrong number down. There's nothing wrong with that. I find that not to be a problem. Okay? We can easily figure out just to read slower, but mathing is math. All
This is
right.
49.
So subtract out the 9, you get 18x is what is that, 126?
Yeah.
Divide it out, you get what?
7.
Okay. Now, it asked us to figure out which angle. Was it the
BDC.
EDC? Okay. Take our 7.
You're gonna get 86.
11 times 7 is
77. It's
Add 90.
76. What is it?
Yeah.
You should get 86.
And then that other one is 49.
Whichever. Okay. We all right with that?
Yeah. Can we just like do our homework now?
Trying to think we'll have time to get to the, yeah, because we're not going to get to bisectors today.
Oh, what is it? What's what you said?
Would you,
Bisectors?
angle bisectors, it's something different.
Oh, I know what
So-
it is.
So tonight what we'll do, because we'll have to get to angle bisectors tomorrow, and just like we had segment, All right, we'll do those four for tonight. They're just these wind up being 2 of them are straight angle addition, like the examples we just did. The other 2, 29 and 30, they look like this. Well, you have 1, 2, you have 3 angles, where they're going to give you this angle is so much, this angle is so much, this angle is so much, or maybe the whole thing is so much. So you might have to piece it together a little bit. Just write it out. Yes, ma'am.
What's the?
Numbers? This just means do
No,
numbers.
no, what's the one above that? Is that a 5?
No, numbers.
It's okay.
So I got those 4 problems for you. If you guys give me a second, I will put it up on the board so you can take a picture of it, so you can have those 4 problems here for you, all right?
Whoa. We can potentially get double homework.